Hello everybody, my name's Kyle Nickerson. I'm going to be presenting this poster today, which is joint work with my supervisor, Dr. Ting. And before I get into the poster, I just wanted to say that this kind of line of research, there's two main groups of people who I think might find this interesting. The first group is basically genetic programming researchers who are interested in population diversity on the one hand, and then on the other hand, people who are interested in this MAP-Elites algorithm and just interested in seeing different ways of applying it. So I'll kind of get into the scenario that we're looking at in this work. Basically, we're looking at just like a very generic binary classification scenario with genetic programming. So we're trying to predict the label, which is going to be either 0 or 1, given a vector of some real valued features. And we'd like for this to be a fairly generic technique, so we've tested our method on a bunch of benchmark data sets from the Penn Machine Learning benchmark repository. And kind of the idea behind what we're doing is that if we'd like to take a bunch of individual genetic programs and combine them into an ensemble classifier, in order for that to work really well, we should have the individual programs should make unique or kind of diverse errors. And the MAP-Elites algorithm is a fairly new algorithm for managing populations and evolutionary algorithms, and it's been really successful at creating more diversity. That's kind of the setup for where we're starting with this work. And so the main problem that we look at this in this paper is how to use MAP-Elites to actually create this error diversity in GPs. And so really, focusing in kind of more what that comes down to is what is a suitable low dimensional behavior descriptor that will allow us to create error diversity. This idea of behavior descriptors is an important part of the MAP-Elites algorithm. And so basically what's going on in this figure here is we've got three different linear genetic programs that all look quite different, but they all compute the same function. So for the same samples, they'll all make exactly the same predictions. But a lot of kind of superficial ways that we can look at these programs, they all look very different. And so the idea is that we should base our behavior descriptors on program meaning and not on the syntax, because these programs can be very syntactically different, but they mean the same thing. And so how do we actually go about doing this? The idea is that we start with kind of an ideal high dimensional description of a program which describes its behavior. And to do that, we basically get our high dimensional vector by just obtaining predictions from the GP models on a bunch of training samples. This idea is actually very similar to the idea of semantic representation that comes up in semantic GP. And then once we have these high dimensional kind of ideal descriptors, in this work what we do is we use a variational autoencoder, which is just a machine learning model that's capable of compressing things. We use that to compress these high dimensional ideal descriptors down into a low dimensional version that can be used with MAP-Elites. And this is just kind of a summary of the results of our method versus some classical machine learning methods, as well as versus basic MAP-Elites, which is just MAP-Elites with some of the syntax-based descriptors. And so as we see, there's kind of, at the end of the day, there's no free lunch. Like our method is not completely better than any of the other existing ones, but it does compare pretty favorably overall. We can also see that, like on average, the average performance of our model tends to do better than the other models. And this score is a balanced accuracy score because we've tried it on both balanced and imbalanced data sets. So all these scores here report balanced accuracy. Yeah, if you'd like to learn more about this work, you can check out my GitHub here. This is the page for this project. It's just got some of the code for running some of the standard machine learning models on this data repository. It's also got my contact information, so if anybody's interested in reaching out, feel free to get my email from there. Send me an email. I'd love to chat more about this. Thank you very much for listening, and I'd be happy to answer any questions. Thank you.